For thousands of years, a crimson star has watched over humanity from the constellation Orion. Bright, reddish, and impossible to ignore, Betelgeuse has fascinated civilizations across history. Ancient skywatchers followed its glow through changing seasons. Sailors used it to navigate dark oceans. Travelers crossing deserts traced Orion's outline overhead, with Betelgeuse marking the shoulder of the celestial hunter. But unlike many stars that shine with steady consistency, Betelgeuse always appeared slightly unpredictable. Its brightness subtly changed over time. Not enough to alarm ancient observers, but enough to inspire curiosity. The star seemed to pulse, to flicker, almost like a distant heartbeat echoing through space. Modern astronomy eventually revealed the truth behind that strange behavior. Betelgeuse is not an ordinary star. It is a red supergiant, one of the largest and most unstable types of stars known to exist. Located roughly 640 light-years from Earth, it is close enough in cosmic terms that the light reaching us tonight began its journey while human civilization was still shaping parts of recorded history. Every beam of starlight from Betelgeuse is therefore a message from the past. A glimpse of history traveling across space. Although its surface temperature is cooler than the Sun's, Betelgeuse shines enormously bright because of its immense size. If placed at the center of our solar system, its outer atmosphere would stretch beyond the orbit of Jupiter. Mercury, Venus, Earth, and Mars would all exist inside the star itself. But beneath that gigantic appearance lies instability. The surface of Betelgeuse is in constant motion. Immense convection cells churn across it as hot plasma rises upward and cooler material sinks back down into the interior. These turbulent regions are so enormous that some could contain entire planetary systems. The star behaves less like a smooth glowing sphere and more like a boiling ocean of fire. Its atmosphere is equally violent. Powerful stellar winds continuously hurl gas and dust into surrounding space, creating expanding clouds extending trillions of kilometers outward. With every eruption, Betelgeuse loses part of itself. But this loss also serves a larger cosmic purpose. The star manufactures heavy elements deep inside its core: carbon, oxygen, nitrogen, and other materials essential for planets and life. As those elements are expelled into space, they become part of the raw material from which future solar systems may someday form. In that sense, stars like Betelgeuse are cosmic engines of renewal. Yet they cannot continue forever. Red supergiants survive through a delicate balance. Gravity constantly pulls inward while energy from nuclear fusion pushes outward. As the star ages, that balance becomes increasingly unstable. Eventually, gravity will win. And when that happens, Betelgeuse will experience one of the most powerful transformations in the universe. But before that final moment arrives, the star has already shown signs of its chaotic nature. In late 2019 and early 2020, astronomers witnessed something extraordinary. Betelgeuse suddenly dimmed. Its brightness dropped dramatically, becoming visibly fainter even to casual skywatchers. Around the world, observatories turned their instruments toward Orion. Speculation spread rapidly. Was the star preparing to explode? Had humanity begun witnessing the early stages of a supernova in real time? For a brief moment, it seemed possible. But the explanation proved more complex. Betelgeuse had not begun dying. Instead, it had partially hidden itself behind a massive cloud of gas and dust ejected from its own surface. The star had essentially obscured its own light. And in doing so, it reminded scientists just how unpredictable massive stars can be. Deep inside Betelgeuse, nuclear fusion continues relentlessly. Hydrogen transforms into helium. Helium fuses into heavier elements. Layer upon layer of reactions occur deep within the star's interior, building increasingly massive atomic nuclei. But this process has a limit. Eventually, iron begins forming inside the core. And iron changes everything. Unlike lighter elements, iron does not release energy when fused. Instead, it absorbs energy. Once enough iron accumulates, the star can no longer support its own immense weight. At that moment, collapse begins. Gravity overwhelms the core in seconds. The interior compresses catastrophically while shock waves erupt outward through the star's outer layers. The result is a supernova, one of the most energetic explosions in existence. For a brief period, Betelgeuse could shine brighter than nearly every star in the night sky. Some models suggest it may even become visible during daylight. At night, it could cast faint shadows across Earth. Yet despite its enormous power, the explosion would pose no direct danger to humanity. The star is far enough away that the event would be spectacular rather than destructive. But one mystery remains impossible to answer precisely. When will it happen? The explosion could occur tomorrow. Or tens of thousands of years from now. From a human perspective, both possibilities are equally plausible. And because light itself requires time to travel, another possibility exists that feels almost unsettling. Betelgeuse may have already exploded. Its final burst of light could already be racing toward Earth through interstellar space while humanity remains unaware. Until that signal arrives, the star continues its unstable existence. Its surface erupts unpredictably. Dust clouds form and disperse. Massive pulses ripple through its outer layers. Each observation reveals new complexities that challenge older theories about how giant stars behave. Astronomers monitor it constantly, studying every fluctuation in brightness and every subtle shift in its spectrum. Yet despite modern technology, Betelgeuse still resists complete understanding. It remains a reminder that the universe is not static. Even familiar stars visible to the naked eye are dynamic systems shaped by immense forces operating across incomprehensible timescales. And when Betelgeuse finally explodes, the event will not simply mark an ending. The star's outer layers will scatter across space, enriching interstellar clouds with heavy elements forged over millions of years. Those materials may someday become new stars, new planets, perhaps even new life. In that way, the death of a massive star becomes part of a larger cosmic cycle, destruction giving rise to creation. For now, Betelgeuse still burns above Orion, glowing red against the darkness. Unstable, ancient, and slowly moving toward a transformation that will one day rewrite the sky itself.